Hi students. So today we'll discuss electrostatics. What is mean by electrostatics now? Electro means charges. Statics means what? So charges are at rest. So when the charges are at rest, so what will happen now? That it will create some field and it will exert the force on the other charges now, and it will create some like number of field lines onto this one. No? So like this all the things. No, when their charges are at rest. No, so these are the effect will be shown by the charges now. That study of that effect shown by the charges when they are at rest. No, we will call it as like a electrostatics. That means electrostatics means when their charges are at rest. Clear? So therefore we know that, first of all let us go for basics onto this one. No? We know that atom, what is the charge on the atom now? Therefore atoms are said to be like a neutral, right? So therefore we know that we already studied like cathode rays, Bohr's atomic model, lot of things are there. So how the atom it will be there, basic model of the atom. So nucleus will be present at the center of this one. No? So here electrons are revolving now. So electrons are revolving. So we know that here it contains like a electrons here. No, these electrons, no, these electrons are negatively charged, right? So negatively charged particles. No, therefore right. So electrons are negatively charged particles. No, so which will be revolving around the nucleus. No, so inside this one, no, there is protons are there. Protons, so are positively charged particles, right? Why these electrons are named it as positive? Why these electrons are named it as negative? So why protons are said to be like a positively charged? So that also we'll discuss in this chapter. No, so why that is given? What is mean by negativity? Negative means what, right? So that also we'll discuss. No, and these all are how many number of electrons are there, so that many number of protons will be there. So the charge of the electron and charge of the proton, it will be the same. Charge of the electron, charge of the proton is same, but it will be the different polarity. Therefore one it will be the opposite to the other. So therefore number of electrons, it will be equal to number of protons. And we know charge of the electron, charge of the proton both are same. No, therefore net charge on this one, no, it will be always equal to 0 for a neutral atom, right? So we know that. So therefore a neutral atom contains same number of electrons and same number of protons now. So but what we are doing now, sometimes we will do some simple experiments. No, so we will take one glass rod and silk cloth. So we will rub this one. No, and we'll keep the glass rod to the one paper. So definitely the paper, bit of the paper will attract. Even we will do this one. No, we'll take one pen and we'll rub it on our head. No, so therefore due to that friction, no, so this it will become some charge. If you keep near to the bit of the paper, it will attract. No, so when you are rubbing, what is happening now? What is happening now? When they are rubbing, no, they are attracting. So because so they are generating the some amount of charges there now. Therefore how the charges will be this atom, how it can be charged onto this one now? So these protons which are there now, this nucleus, it is impossible to remove the protons from this one now. So what we can do, therefore due to the rubbing, these electrons are weakly attracted onto this one now. Electrons are easily can be removed and easily can be added onto this one now. Therefore only electron motion it will be takes place here now. So suppose if any one substance is there, so if it is losing the electrons, suppose we will take the one same thing. Let us take, this is your glass rod, this is your so glass rod, and we will take it as one silk cloth here now. This is one silk cloth. So silk cloth. So what happens now? Due to this one now, due to the silk cloth and glass rod, no, so we'll rub it each other now. So initially both are neutral onto this one now. Due to rubbing, therefore they are going to become like a charged. So what will happen now? How they will become charged now? So some of the electrons from the glass rod will go to the silk cloth, and from the some of the electrons from the silk cloth to the glass rod. See, therefore here what happened now? Here electrons can be removed or can be added. If there is a loss of electrons are there, what will happen now? Loss of electrons, negativity is decreased. Negativity decreased means electrons See, number of electrons are decreased means positivity will be increased. So negativity will be decreased. Negativity will be decreased, positivity is increased. So when there is a loss of electrons is there, so that body will become like a positively charged. Suppose if there is a gain of electrons are there, gain of electrons. If there is a gain of electrons are there, what happen now? Large number of electrons are given to this one now. So what will happen now? Negativity is increased. So positivity will decrease. Therefore, more number of electrons are there. So therefore, this will become like a negatively charged. Clear? So if you are adding the electrons or if you are losing the electrons, therefore it will become like a charged body onto this. How it will be? Loss of electron become positively charged, gain of electron will become like a negatively charged onto this. Here the same thing it will happen no, when you are rubbing onto this one no. So therefore some amount of electrons will be transferred from glass rod to silk cloth. Therefore some number of electrons are transferred from this one now. So this glass rod, what is happening now? There will be a loss of electrons. Loss of electrons means what will happen now? It will become like a positively charged. So therefore this silk cloth, what will happen now? It will be gain of electrons. So if it is gain of electrons now, what will happen now? Negatively charged here now. So here it is losing now. Therefore here it will become like a positively charged here now. This is become like a positively charged, and this will become like a negatively charged now. Right? So you know we cannot create the charges and we cannot destroy the charges no. Therefore how many number of electrons are lost from the glass rod, so that many number of electrons will be gained by the silk cloth now. This is nothing but a law of conservation of charges. Therefore number of electrons lost, so will be equal to number of electrons gained by the silk cloth. Clear? So this lead to the law of conservation of charges now. So suppose here some electrons, n electrons are lost now. What will happen now? What will be the charge on the glass rod now? Charge on the glass rod, it will be equal to, therefore plus number of electrons into charge of the electron. This much amount of charge it will be gain onto this one now. So therefore that means this much amount of positively charged so body onto this. Therefore here what will happen now? This silk cloth will gain the electrons now. What will be the charge on this one now? Minus Ne. So this much amount of charge it will be so gained by the silk cloth now. Clear? So you know charge of the electron was given by, charge of the electron is how much now? What is the charge of the electron? 1.6 into 10 to the power of minus 19 coulombs. So this it will be the charge of the electron negative. So charge of the proton is also positive. 1.6 into 10 to the power of minus 19. So in this way you can calculate so number of amount of charge present on the glass rod, amount of charge present in the silk cloth. Clear? So therefore now, okay, sometimes they may ask you, is there is a mass transfer? So transfer of mass is taken place or not? Yes, because electrons are transferred from this one now. So this it will become like a loss of mass now. You know the mass of the electron. What is the mass of the electron now? That is nothing but a 9.1 into 10 to the power of minus 31 kg. Minus 31 means is a very minute no. So that's why we cannot able to observe maximum change onto this. Clear? So 10 to the power of minus 31 now. What is the mass of this one now? Therefore mass is lost. Therefore loss of mass. How much it will be now? Therefore number of electrons into mass of the electron. This much amount of mass is lost by this one now, and that much amount of mass it will be gained by this one. Clear? So even mass transfer also it will be takes place. So this is a charging. We are making the charged body is because of due to the friction here now. This is here friction. So making the charged body because of due to the friction. So like this. Not only this glass rod and silk cloth, therefore amber and fur, right, like a lot of other materials also is there, will show the exhibit these type of phenomena. So now clear? Now here now we want to write, so Q is equals to Ne. We will do one simple question onto this one. No? So here we can see one more phenomenon. No, see here. Therefore here this glass rod is losing the some number of electrons. No, silk cloth is gaining some number of electrons. So here electrons will be transferred like half electron, 1/4 of the electron, like that it is not able to possible. Therefore here 1 electron or 2 electron or 100 electron or 1000 electron or million electron like that only will be there like a half electron. So like that it is not possible onto this to transfer the electrons from here here to there. So this lead to the quantization of the charges So we need to take it as like a q is equals to, therefore n is nothing but a number of electrons onto this into charge of this Clear? So now in this way we can make the charged bodies because of due to the friction onto this. Now we will see one more concept we can make the charged bodies so in a different method also. One is conduction and another one is convection Both the things we will combinedly will explain here Let us take one steel body here This is one steel body, this is one body here Okay. So this is now it is placed on one insulating stand here This is one insulating stand. So this is placed. Therefore upon to this there is a certain amount of charges are there. Suppose here negative charges are there. Negative charges are there means what? A large number of electrons are added to this Negative charges are there. This is your insulating stand. Insulating stand means charges will not be able to flow through this ground. So now the charges, it is a charged body. Clear? Now we will take, this is your metal compulsory. Here it should be like a metal conductor. Now we will take one more charged body here Therefore one more steel ball, right? So now what we will do now, this steel ball is there identical steel ball. So this also placed in a one insulating stand onto this identical steel ball. Now this is uncharged. If it is uncharged. So now what we will do now, therefore now these two what we will do now, we will make it into contact onto this. So when you are make it into contact here therefore when they are in contact to this therefore we are connecting this. So what will happen now, this is uncharged, this is charged onto this. Therefore here it is having large number of electrons. So this electrons will be supplied to this this will become like a negatively charged onto this. Therefore some number of charges it will be able to loss inside this some charges will be get lost and some charges will be get accumulated onto this Right? The charges will flow until the potential on this and potential on this is both becomes equal. Till that time therefore the charges will flow. So therefore the charges will comes to stop. So until the potential on this and potential on this it will become same. If the potentials are become same, so further charges will not be able to flow onto this. Now therefore if you separate it therefore what will happen now, this will become certain amount of charged body, this also will become charged body. So here contact is there contact is there. So that's why the charges will be able to make, we can make the charged body by conduction onto this. So if they are identical, so how much amount of charge will be there So therefore the charge on this one, suppose Q1, initially the charge on this one is suppose Q2. If they are identical, I am telling identical only. So what will be the final charge on this one now? Final charge it will be equal to Q1 plus Q2 by 2. Therefore this it will be the average one. This formula is applicable for only if they are identical. If they are not identical is there, so therefore this formula we should not take it. We have to take potential on this one potential on this one make it equal, then we will be able to find it. So that type of concepts we will discuss in the coming chapters onto this. So now right now we will take it as identical. The total net charge that will be final charge accumulated on this one will become like a equally divided between them. If one is negative, one is positive, which is negative you would use minus, which is positive that you take it as positive only, right? If both are negative, minus minus no. If both are positive, positive positive only you would take it onto this. Clear? So in this way we can calculate. So we can make the charged body. This is called conduction method. So this is your conducting. Clear? So now we'll go for induction method. Now we'll go for induction method. Induction method means what? There should not be no contact, no physical contact. So to takes place this one therefore first of all you should know basic things like charges, like positive charge So what will happen now? They are going to repel each other. So positive and negative, therefore they are going to attract each other. You know, positive charge and positive charge. So like charges, what will happen now? Like charges will repel. So unlike charges will attract. So we'll use this concept, you might have studied in your lower classes, no? So this concept. So now we'll use this concept now. We will calculate, we'll make a charged body onto this. So this is also one important concept, no? See here, there is a one, this is one sphere is there. So this is placed on a insulating stand here now, insulating stand. So this is certain amount of charge here now. Therefore, here some amount of positively charged here now, the positive charge is there, some charge is there on this. Okay. So positively charged. Now what I will do, I will take one more identical one now, but I will keep it very near to this one now. Therefore, this is uncharged. So uncharged metallic sphere now, what I will do, I will keep it very near to this. So therefore, what will happen now, when we are keeping here now, there is no contact, compulsory there should not be any contact onto this. So what this it will do now, these are positive charges now, it will try to attract the negative charges. Therefore, when you keep it here very near to this one now, all negative charges will comes to here and all positive charges now will go away onto this. Clear? So again if you remove it now, therefore again these two will be there, therefore again it will get neutralized onto this. But now if I want to make this as your charged body onto this one now, so when you are keeping now, we want to remove these positive charges. How we are going to remove these positive charges now? So we are going to connect this one now, therefore to the earthing, right? So this earthing now, right? So we are going to give earthing now. So what will happen now? Earth is what is ready to supply the charges now, and it is ready to take the charges also. Earthing, the potential is always equal to 0, ready to take, ready to give. So this side is positive charges are there. So what will happen now, when positive charges are there, so here these positive charges are there here now. So this part, so it will try to pull the electrons here now. Therefore, here electrons it will be able to move from to this one now. One electron which is entered, this positive charge it will go, like that electrons will flow to this one now until the total charge on this one now will become vanishes onto this, right? So it will able to flow it, this all positive charges will be able to flow to this ground. Now what I will do, I will just disconnect it now. Then what I will do now, just I will disconnect it, then I will separate this one now. When I am going to separate this after disconnecting now, so therefore there will be say negative charges are there when you disconnected it out of, therefore we kept it aside onto this one now, out of the field of this. So these negative charges are there. So it will try to make it like a neutral, but there is no other positive charges are there now. So therefore it will still remains like a some amount of negative charges now, it will be able to present in the body. In this way we can make it like a negatively charged body. So therefore without any contact here now, we are going to make this charged body. So this process we will call it as like a induction method. So what is the frictional method now? Therefore we are going to rub so with two objects now, due to the friction, so it will make it like charged body, or one charged body is there connected to the another directly charged body by the one conducting wire. So automatically the charges will flow from one body to another body, that is called conduction. But without making in contact, therefore we are keeping very near to this one now, because of due to one field, one charged field, it will induces the charge on the other object now. So but it should be compulsory these to be conductors only. Here I will bring like some wood onto this one, it is not possible onto this one. So for this one, enormous amount of charge is required. We are going to take it like metal, but there should not be any contact. This is creating the field here. Due to that field, the charges are induced. That extra which is charges are which is induced, that we are going to remove by earthing now. Then remaining other charges now, it will stay like that only. Therefore, it will become like a charged one. So without any contact, so we are making the charged body. So that is said to be like a induction method onto this. Clear? So in this way, we can make a charged bodies now, right? In our in this class itself, why electrons are negatively charged, what is meant by negative charge and what is meant by positive charge now. So how it is there now. So when this first experiment was done, therefore this experiment, that is glass rod and silk cloth, no, when this experiment was done, no, so we can do it here one thing. So we'll make a charged body. Therefore what I will do, I will make it as like a one glass rod. I am going to keep it here now. So this is one glass rod freely suspended here now. Now again the same way, therefore glass rod, so due to glass rod and silk cloth, no, rubbing, so it is gaining some amount of property. Which property we don't know actually at the time, at the starting time, olden days, no, so which property it is gained we don't know. Therefore like that same glass rod, and again same silk cloth, other part of this one, no. So one more same glass rod, what we are going to do now, so we are going to make it like a, so we are going to bring it very near to this one now. So this is having the same property, this also is having the same property. So what is happening now, like charges now, therefore this rod is going to get repel each other now, right? That means like properties will repel each other. Now again the same experiment is done. They don't know at the time there is a one electron is there like that, no, these all are the things, no. In the olden days they don't know about this one, no. So therefore this is one glass rod, no, again it is induced some property onto this. Now here what I am going to do now, I am going to take it as like a, therefore I am going to bring like a silk cloth. So when I am bringing like a opposite one onto this one now, so this glass rod is getting attracted to the silk cloth onto this. So that means, so these two are identical properties, no, they are repelling, therefore they are non-identical properties gaining onto this one, no, they are attracting, right? Like that, like things, no, will repel, unlike things, no, are attracts. Like that they thought that this is like a positive onto this one, no. So then this is positively we thought, no, and only positive and negative, no, therefore definitely we thought it as like a negative onto this. So therefore like that one standard thing is required now, like therefore which one is positive and which is negative, for that one standard thing is required. They took it as like a glass rod and silk cloth. So glass rod is taken as like a positive one, no, and silk cloth is taken as like a negative one, no. Anything which is attracting to the positive glass rod, no, that is said to be negative. So anything which is repelling to the glass rod, that is said to be positive onto this, right? Like that. So we came like a positive, negative, so which is positive and which is negative. So like this we got the idea of this one now. Clear? So here, so because of due to this positive charge, no, so like charges, so will repel, and unlike charges, no, this is one positive, no, so therefore unlike charges, no, unlike charges will attract. Clear? So in this way, therefore electrons and this all are, no, is given as different type of charges on this. Clear? Now so we'll go for here. We already studied that for here certain amount of charged body, no. So it's charged bodies, what happening now, they are attracting each other or repelling each other, there will be a force is there. So therefore the force between them was calculated by the Coulomb's law, right? What is Coulomb's law of force now? Coulomb's law. So what is this Coulomb's law now, right? Coulombic force, no, therefore there is a charges are there. This is one charge q1, we'll take it as 1 point charge now. So another one more charge we will take it now, q2. So these two are separated by r distance. So point charges only we are going to take it, no, point charges. Therefore so they are separated by some distance, no. The force of attraction based on the, see, if they both are positive charges, no, they repel each other, no. If one is positive and negative, no, they will attract each other. Always you have to identify the direction of the force by seeing the charges positive or negative. Clear? So therefore here, so we can take it as these two are repels onto this one, no. Suppose these are both are positive charges, no. So they will go into repel. In which direction they will act now? This force, it will act along the straight line joining between these two charges. They will exert the force in this direction. Clear? So what is the force here now? Force is directly proportional to the product of these charges now. What is the charges now? q1 into q2, and inversely proportional to the square of the distance. This was given by Coulomb's law. So if you remove this proportionality, so what is the force here now? Force, it will act along the line joining, straight line joining between the 2 point charges. So if I remove this proportionality, k is nothing but a q1 q2 by r square. So this k we got it as like a F is equals to, so this it will depends upon the medium where we are placing onto this one. No? For air or vacuum, no, we can rewrite it as 1 by 4 pi epsilon naught into Q1 Q2 by R square. Clear? So why 1 by 4 pi means also we'll discuss. It will exert the field in all the three dimensional, no, like a spherical influence will be there. 4 pi R square, nothing but the area of the sphere, like that you can get it now. Where epsilon naught is nothing but a permittivity of the free space now, right? So 1 by 4 pi epsilon naught, so it is given as this value 9 into 10 to the power of 9. What is this value now? Newton into meter square by Coulomb square. This is the value for air or vacuum onto this one. Clear? So similarly, this force between the two charges now also depends upon the medium where we are keeping onto this. So therefore, this is for air or vacuum. No? Air or vacuum. So suppose for any other medium, no, medium. So what you can write it now? 1 by, so 4 pi epsilon, right, into Q1 Q2 by R square. Clear? So therefore, how to convert it onto this one now for a different media onto this one? No? So you can rewrite it as, so relative permittivity. So therefore, epsilon R we can rewrite it as, so epsilon by epsilon naught. So you can rewrite it as, here it is inversely proportional, no. So therefore, force of the two charges when they are kept in air by force when they are kept in the medium. In this way, so you can calculate it, no. Epsilon is equals to epsilon R into epsilon naught. You can substitute it, no. Therefore, you can get the force on the medium. In the medium, if it is completely filled in a certain medium onto this. Now we will study about this permittivity, right? So right, students. So here we'll study the value about this one. No? So 1 by sorry, here, no, right. So absolute permittivity, therefore permittivity of free space, no, what is the value here? No, 1 by 4 pi epsilon naught is equals to 9 into 10 to the power of 9. Epsilon naught, what you can write it now? 1 by 4 pi into 9 into 10 to the power of 9. So if you really calculate of this one, no, therefore you will get it as 8.854 into 10 to the power of minus 12. So what is the unit here now? Unit. So here you can take it, no, Coulomb square by therefore force into meter square. Therefore here Coulomb. So Coulomb square by therefore Newton into meter square. This is your absolute permittivity of our free space now. Clear? So most important. So what is the dimensional formula for this one now? So dimensional formula for this one now. See, Coulomb. Coulomb is a unit of right. Coulomb can be written as like a ampere into time, right? Why? Because current it will be equal to charge by time. So charge is equals to current into time. Current is a fundamental quantity. So therefore A or TA whole square by Newton. Therefore M1 L1 T minus 2 into L square. Clear? So therefore M minus 1 L to the power of minus 3. So T to the power of 4 A square. So this is your dimensional formula for permittivity of the free space now, right? Similarly, relative permittivity, so you can rewrite it as, that is epsilon by epsilon naught. So permittivity of any medium, no, therefore you can write down epsilon R into epsilon naught. So you can rewrite it as, or this is called also can write it as like a dielectric constant onto this. Clear? So these are the some basic formulas, no, and force is also inversely proportional to the square of the distance. So here Coulombic force, therefore it is inversely proportional. You can draw the graph here, no. So force and the distance, no, therefore it is inversely proportional between the two charges now. Clear? Now we can have different questions, no, different problems related to this Coulombs now. So let us see now. So here we'll go for one question here, no, very simple questions, no. So let us see here one simple question. So let us assume that 5 microcoulomb is separated by, therefore here 10 microcoulomb, therefore separated by 10 meter distance. What will be the force acting on this? Simple question, no? So 1 by 4 pi epsilon naught, therefore this is your air, if they are air, no? If they are kept in the air. What is the formula? 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught into q1 q2 by r square. So 9 into 10 the power of 9 into 5 into 10 the power of minus 6 into 10 into 10 the power of minus 6 divided by r square means nothing but a 100. 10 square is nothing but a 100. So you can write it as simple now to this. Therefore, if I take it here now, therefore here it will be 9 into 10 the power of 10, this 9 and 10. So this is 12, therefore here it is also 2, you can take it now, therefore minus 12, therefore it is into 5 into 10 the power of minus 12. So 45 into 10 the power of minus 2, therefore 0.45 newtons. Clear? Clear? So therefore suppose if these two charges no is kept in a certain medium, some medium, no, one filled with a certain medium, some medium is there whose relative permittivity is nothing but a 6 now, right? So find the force in the medium. So what will be the force in the medium now? You can rewrite it as, so just now we written now, therefore epsilon permittivity, so you can write down epsilon by epsilon naught r, so force in the air by, therefore force in the medium. So what I can write down, force in the medium is nothing but a force in the air divided by, it will be the 6 now. Clear? So force in the air is how much now? You got it as 0.45 or 45 into 10 the power of minus 2 divided by 6 now. So 3 2s are, therefore 3 1s are 15, therefore 2 1s are 2, 7.5, therefore 7.5 into 10 the power of minus 2 Newton. This is the, so force if they are kept in the some medium, no? So whose relative permittivity is 6 now. Clear? So like that you can calculate it, no? So the force between them, no? And one more concept, no? So here if there is a some charges, okay, they can take it as like a null point. What is a null point here now? Null point. Null point. So here now you can take it as like one charge q1, okay? So another charge it is q2, therefore these two are separated by distances r. So therefore here what we will do now, we will calculate null point. That means we want to keep one small test charge here so that it should experience a zero force. Null point means nothing but what? So force should be equal to 0, null point. So at what point we have to keep the charge so that it will becomes to the 0. Both are positive charges here now. We will take it as positive charges. If it is negative charges, one is negative is there now, therefore different position. We will see that. Okay. So here suppose we will calculate x distance, no, remaining distance is nothing but a r minus x. Clear? So this charge, what will do now? This positive and positive. So what will happen now? This is going to repel onto this. This is due to F1 and this positive and this is also positive charge. Test charge is positive charge now. So this side it will be the F2 because repulsion force now. So if these forces want to be 0, that means, so force want to be 0 means this side force and this side force should be both are equal. That means F1 should be equal to F2 magnitude wise, right? So what is F1 now? Therefore 1 by 4 pi epsilon naught into, therefore q1 into q by x square is equals to 1 by 4 pi epsilon naught into q2 into q divided by r minus x whole square. So get cancel out, therefore this is 0. I mean this also cancel onto this one. So what you will get it now? This I can rewrite it as root 2 of q1 by x whole square. It is nothing but a root q2 by r minus x whole square. Clear? So these powers are same. So these bases are also should be equated here now. Now you can write it as root q1 by x is equals to root q2 by r minus x. Taken here now, multiply it now, root q1 into r, this is minus x now, taken toward this side, x taken common, root q1 plus root q2. Clear? So x is equals to root q1 by root q1 plus root q2 into R. This is your x. Clear? So this x depends on what factors? No, depends upon the q value. If it is q is larger, this q is larger, no, so therefore x is also larger. So that means, so always null point, no, will forms near to the lower charged particle, no. Therefore, so if this is among this one, no, so this is having lower charge means, so this null point is forms near to this one, no. Suppose this is lower charge means null point will be formed toward this one, near to this. Clear? So x is equals to proportional to root q1. If they are asking what will be the other distance from q2, so what you can write it now? Simple thing. Therefore, you can write it as, so this is, you can get it as r minus x. Therefore, this is a distance from q2. This is a distance from q1. So null point is a distance from q1. So this is from q1 charge, right? So therefore, this is a distance from q2 charge. Therefore, what you will get it now? Therefore, root q2 by root q1 plus root q2 into r. This is your, so null point, so which can be formed onto this one. Clear? In this way, you can calculate, so the null point of this one. If there are identical positive charges are there, if there are positive charges are there, if it is one of these negative charges there, therefore it will not form in between these one. Why it will not form? Let us see one simple question, no? So let us see. Okay, so we can see some different questions here, no? So here there is a 9 microcoulomb of the charge is there, no? So therefore here 16 microcoulomb charge is there, no? So this is separated by, so 10 meter distance, no? We want to calculate, so both are positive, no? Therefore we want to calculate, so null point from this one, no? Therefore some charge we have to keep it. Clear? And this null point, no, does not depend upon which charge we are keeping onto this, right? Q is not present inside this one. See, null point does not depend upon the, what is the test charge? This is a test charge. Clear? It does not depend upon the test charge now. Now, so here we want to calculate, this is Q. So this is here x distance. Therefore, this it will be a 10 minus x distance. How to do it now? Very simple one, no? Therefore, here you need to write this one, no, charge, this charge, no, that is nothing but a root, so 9 microcoulomb. So therefore, divided by micro also it will get cancelled out onto this, root 9 by x whole square. So it will be equal to, therefore, root 16 by, therefore 10 minus x whole square. So like this you can rewrite it as, therefore this it will be 3 by x, it will be equal to 4 by 10 minus x. Therefore you can take it as 30 minus 3x is equals to 4x. So x, therefore 7x, so 30 by 7 meters. This is your x distance now. Clear? In this way you can calculate it now. And one more question now. Suppose the same question, no, we'll see. So one is here plus 9 microcoulomb we are keeping, no. So another one more, therefore here minus, so 16 microcoulomb we are keeping here now. So this is your 10 meter distance, right? So therefore here the null point. So is the null point will be formed in between these one, no? Yes or no? No, we'll check it now. Therefore this is Q, this is positive, and this also positive, repulsion will take place. This is negative, positive, attraction will take place. If the both the forces are acting in the same direction, no, so it will never exerts, therefore zero force onto this one. Clear? Therefore now what we will do now? Therefore there is a chances are there. So here you can take it now. So why this charge is low? This charge is very high around to this one, no? Here the charges are possible. Why? Therefore you can take it as plus 9 microcoulomb, no? Therefore it will be going to get repel onto this. So this is minus, no? Therefore this is going to attract here now. So this is your x distance, no? And this distance is nothing but a 10 plus x distance. Clear? Now we will calculate this one now. How? So therefore again the same thing, no? Therefore root 9 by x whole square, so is equals to root 16 by 10 plus x whole square. Clear? So just now we did this one now. Therefore 3 by x is equals to 4 by 10 plus x. So taken here now, 30 plus 3x is equals to 4x. So therefore x is equals to 30 meters. So x is equals to 30 meter. That means this should be very, very large distance. No, 30-meter distance you have to go for this. So there null point it will be formed because of due to this negative charges. This negative. Clear? And if both the negatives are there, therefore definitely it will form again in the middle. One is positive, one is negative, means like this you have to find it out to this one. Clear? So be careful on this, the polarity of these charges on this one. Clear? Now we will go for another concept. No? See here. Suppose if the charges are kept, right? So if the charges are kept, identical charges, when they are kept at corners of a square of this one. This is your L. Now we want to calculate the force acting on any one of this charge now. So what will be the force? How to calculate now? So first let us calculate force on any one of the charge. Force on any one charge we want to calculate. So what will be the force on this one, any one charge now? So these two charges, what will happen now? They are undergo like a repulsion onto this. This is undergo like a repulsion. Therefore, a straight line joining between this one. What is this formula? KQ square by L square. Clear? So these two are also it is undergoing now. Therefore, KQ square by L square. Clear? So these two forces are perpendicular onto this. If any time two forces are perpendicular onto this one, no? Forces are perpendicular. Resultant force is nothing but a root 2 into F. Clear? Now, what will be the this one now? This is nothing but a root 2 into KQ square by L square. Clear? So, not only these two, this one more charge is also is there. One more is there now. Therefore, here what you will get it now? This also will exert the force onto this. What is this distance now? Root 2 into L. This side is also force will be there. How much now? K into Q square by root 2 into L, therefore 2L square. So what will be the force here now? Force on any one of the charge. In this charge, no? Force. Because of due to this resultant is like this, therefore these two forces are acting in the same direction, no? So KQ square by, therefore 2L square plus root 2 into KQ square by L square. Therefore KQ square by L square root 2 plus 1 by 2 will be the force acting on this. And all are identical now. Therefore, if any time one, right, if any time in one of the charge it will be the reverse onto this, definitely it will be the entire thing, it will be the different onto this. Always you have to find it, if there are positive charges are there, repulsion no, if there are negative charges and positive charges there no, they will attract. So that you have to stick on to that, then you can able to solve the problems very easily. Okay. So same type of question no, suppose here Q is there, so therefore it is minus Q is then, here plus Q is there, therefore plus Q is there. So now we want to calculate what is the force acting on this charge, force acting on this charge now we want to calculate it. What is the force acting on this one now? Force acting on this. So here this is negative charge, no? Negative charge, this is negative charge, right? So this is negative charge and positive charge. What will happen now? This will experience a force toward this side. How much now? KQ square by L square. So due to this one now, what will happen now? They undergo like a repulsion onto this. Clear? Right? So now what you will get it now? Here KQ square no? So K therefore Q square by L square. So how are they now? Therefore these two like let us see one more thing no? This force. So what is this force? This it will undergo like a K Q square. This distance is root 2 into L, therefore 2L square. This is the force. Clear? Now what I will do now? Okay. So this force is there no? This what I will do? I will split this one into two components. Okay. So this force what I will do now? I'll take these two components here now. So this is 45 degree here now, 45 degree. So what you will get it now? Therefore here, so K into Q square by 2L square into, so sin 45, this is your sin 45, this is your cos 45, that is nothing but a 1 by root 2. Therefore this also K into Q square by 2L square into 1 by root 2. So what will be the different forces now here? What are the forces are acting on this point? Now, upon to this one now, there are two forces. One is KQ square by L square. Here, kq square by L square into 2 root 2. Therefore, what are the forces now? Therefore, kq square by L square is taken as one constant now. Suppose I will take it as kq square by L square as nothing but a, suppose I will take it as x. Okay. Therefore, here what I will get it now? X by 2 root 2. This is your x. Therefore, here x by, therefore 2 root 2. So, this is your x, right? Therefore, x by 2 root 2. Therefore, this side it will be the x. So, this side it is nothing but a x plus x by 2 root 2. Clear? Now, this is x by 2 root 2, this is smaller, therefore you can take it here now, top onto this, therefore r you can rewrite it as this, you can take it, right? So, x minus this, it will become like a x taken common, therefore 2 root 2 plus 1 by 2 root 2, right? 2 root 2 plus 1 by 2 root 2, therefore here you can write down, so x taken common, therefore, so 1 minus 2 root 2, 2 root 2 minus 1 by 2 root 2, clear? Now, therefore, this you can take it as both are acting at 90 degree onto this one, no? So, therefore, you can write it as like a root of, so this 2 root 2 x square, clear? This 2 root 2, this you can take it as resultant onto this one, no? Therefore, root 2 or root of f1 square, root of f1 square plus f2 square, like this you can rewrite it as. Clear? You can solve it now, right? Or you can represent in terms of like a x axis and y axis also, you can just represent it now. Therefore, if you take it as here, this side it is your x axis and this side, right? If you take it as your x and y, this side it is y. So, force on this one is nothing but a 2 root 2 minus 1 by 2 root 2. So, therefore, kq square by L square, therefore, along the j cap upward, right? So, plus 2 root 2 plus 1 by 2 root 2, therefore, so kq square by L square, therefore, I cap. In this way also you can rewrite this formula. Clear? So, like this, see, one is changing, no, everything it will be able to change. You need to be able to identify and you should be able to solve it. Clear? Now, suppose here there is a equilateral triangle is there, therefore the other charges are there here, no, charges q, q and q. Now, this is L, this is L, equilateral triangle means 60 degree, clear? So, what will be the force acting on this one now? Force acting on this, it will be like this. So, what is this one now? K q square by L square. So, this side also positive, therefore, K q square by L square, clear? What is the angle between them now? Angle between them is nothing but 60 degree. If both the forces are at an angle of both the forces are at same angle onto this one, no, it's 60 degree. So, resultant force is nothing but root 3 into F, clear? Root 3 into F, root 3 into F, therefore, root 3 into kq square by L square, this is the force which is acting on any one of the charge. You can try if any one charge is negative and another charge is positive, so then you can try it different scenarios onto this, clear? Like this you need to solve the problems related to this one, no, right?